Hi dear friends, welcome to my channel. Today I am talking about the multi-quadrant operation of the drive. Generally, the motor operates in two modes. One, motoring, and second mode is braking. In motoring mode, electrical energy converted into mechanical energy that everybody knows, and it supports the motion. But in braking mode, the mechanical energy is converting into electrical energy. Example is regenerative braking. In multi-quadrant operation means four-quadrant operation of the drives. There are some concepts behind it. First one is the motor rotation is anti-clockwise direction is taken as positive and speed is also taken as positive. Motor torque is positive when rate of change of speed is in anti-clockwise direction. Third one is positive load torque is in opposite direction to the positive motor torque. Fourth one is in retardation, motor torque is considered as negative. The fifth point, motor is driving a hoist consisting of a cage with or without load, a rope wound onto a drum to hoist the cage and a balance weight of magnitude greater than that of empty cage but less than that of loaded cage. Sixth point, the load torque of the hoisting mechanism is of active type and assumed to be constant due to negligible friction and windage for low speed hoist. Another point is the speed torque curve of the hoist is represented by vertical line passing to two quadrants. The loaded characteristics is in first and fourth quadrant and unloaded characteristics is in second and third quadrant. Now you are seeing the four quadrant operation diagram of the motor driving a hoist load. Quadrant operation, that is forward motoring operation. In the first quadrant, the load torque acts in the opposite direction to that of rotation. Hence, to drive the loaded hoist up, the motor developed torque must be in the direction of the rotation or must be positive. The power will also be positive, so this quadrant is known as forward motoring quadrant. Fourth quadrant operation, reverse braking quadrant. In fourth quadrant has the downward motion of the loaded cage. As loaded cage has more weight than the balanced weight, to limit the speed of the motion, the motor torque must have opposite polarity with respect to the rotation and act as a brake. The motor torque side is positive, but as speed has negative direction, the power will be negative. This quadrant is designated as reverse braking quadrant. Second quadrant operation, that is forward braking operation. The hoisting up of the unloaded cage is represented in the second quadrant. As the counterweight is heavier than the empty cage, the speed at which hoist moves upwards may reach a very high value. To avoid this, the motor torque must act in the opposite direction of the rotation or motor torque must be negative. The power will be negative though the speed is positive. So this quadrant is known as forward braking quadrant. Third quadrant operation, that is reverse motoring operation. The third quadrant represents the downward motion of the empty cage. Downward journey will be opposed by torque due to counterweight and friction at the transmitting parts. Move cage downwards. The motor torque must be in the direction of the rotation. Electric machine acts as a motor but in the reverse direction compared to first quadrant. The torque is negative as speed is increased. In the negative direction, but the power is positive. This quadrant is known as reverse motoring quadrant. This is the summary of the multi-quadrant operation of the motor. In first quadrant, forward motoring operation, speed is positive, torque is positive, power also positive. In forward braking operation, that is happening in the second quadrant, in that speed is positive, torque is negative, power output is negative. In reverse motoring operation, that is happening in third quadrant, in that speed is negative, torque is negative, power output is positive. In reverse braking operation, that is happening in fourth quadrant, here speed and power output is negative but torque is positive. The upcoming part, it will be published here very soon regarding steady state stability of electric drive and load equalization of the electric drive. Please subscribe my channel and click the bell icon to get the latest videos. Thank you dear friends. If any query, you can comment below. Thank you for watching and see you soon.